In this video, we are going to study human eye and the colorful world. And first, let's discuss about the human eye. We have learned in a previous chapter about the light and some of its properties. In this chapter, we shall use these ideas to study some of the optical phenomena of the nature, and we shall also discuss about rainbow formation and splitting of white light and the blue color of the sky. We are going to study how the human eye works and how it accommodates to the different objects from our eyes at a different distance, and also we'll study about rainbow formation, splitting of white light and blue color of the sky. So human eye is this. Let's first go to this picture, and this is a vitreous humor. This optic nerves is goes to the brain. This is retina. Here is the image forms, and these are the ciliary muscles which controls the focal length of the lens. This is called crystalline lens, and there is aqueous humor in it, and this is where the cataract is formed. We will study later. This is a pupil. This is a opening in the eyes, and this is the iris, which controls the amount of light to be entered in the pupil, and this is the cornea, the outermost layer. The human eye is like a camera, and its lens system forms an image of a light sensitive screen called retina, and this screen is a light sensitive, and it forms the image at light sensitive. This light goes and it bends here at the retina. The image forms. The light enters in the eye through the thin membrane called cornea. So through this cornea thin membrane, light enters in our eyes, and the eyeball is it forms the transparent bulge in the front surface of the eye, shown in the figure 11.1. The eyeball is approximately spherical in shape, and it had a diameter about 2.3 centimeter. Most of the reflection of light rays entering the eye occurs in the outer surface of the cornea. So most of the refraction that happens the outer surface of the cornea, here in this region, and the crystalline lens merely provide a finer adjustment of the focal length. So most of the reflection here, the bending convergence of light happens in this region, and this lens, crystalline lens, merely provide adjustment for the focal length only. And iris is a dark. This is iris here. Iris is a dark muscle diaphragm that controls the size of the pupil, and the pupil regulates and controls the amount of light entering the eyes. The eye lens formed from the inverted. The eye lens forms inverted real image of an object on the retina, and the retina is a delicate membrane having an enormous number of light sensitive cells. So these retina here has a light sensitive cells, and the light sensitive cells get activated upon the luminescence and generate electrical signals, and these electrical signals sent to the brain via optical nerve. So when these cells are sensitized, these send some optic signals, and these optic signals travel through the optic nerve to the brain, and brain interprets the image. Brain interprets these signals and finally process the information so that we perceive the object as they are. So, damaged or the malfunction. If any part of the visual system can damage, there is a significant loss of the visual functioning. And if any of the structure involved in the transmission of light, like cornea, pupil, eye lens, aqueous humor, and the virtuous humor, or those responsible for the conversion of light to electrical impulses, like the retina, or even in the optic nerve, they transmit the electrical impulses to the brain, is damaged. This result in the visual impairment. So if any of these like tissues got damaged, here it can be, here it can be, here it can be, here even it can be from the optic nerve, there will be the visual impairment. The pupil of the eye act like a variable aperture whose size can be varied with the help of the iris. And when light is a very bright, the iris contracts so that it allows less light to enter, and while it is dim, the iris expands and the pupil, so that the pupil can allow the more light to enter in. Thus, the pupil opens completely through the relaxation of the iris. Let's talk about the power of accommodation. What is the power of what is accommodation? Eye lens is composed of the fibrous and jelly-like material. Its curvature can be modified by some extent by the ciliary muscles. So this is a eye lens. This is a eye lens, which is crystalline lens, and these are controlled by the ciliary muscles. These ciliary muscles, contracts and relax, and this causes the focal length changes in the this lens. And when the focal length change, the the focus will be changed. This is how. So this enables us to see the object very clearly, so that it will form uh, a clear image on the retina. It will focus the image on the retina. When you are looking at an object closer, the ciliary muscles contracted. This lens increases the curvature of the eye lens. The eye lens then becomes thicker. Consequently, the focal length of the eye lens become decreased. This enables us to see the nearby objects clearly. So when the focal length decreases, so near object, this will happen near object. And the ciliary muscles, when decreases the focal length, and it decreases the focal length so that it can exactly make the image on retina. And this happens in vice versa in case when object is far. The ability of the eye lens to adjust its focal length is called accommodation. To accommodation, what is accommodation? Accommodation is just this lens ability to adjust its focal length. This is accommodation. We only know that most of the convergence of light happens in the cornea, this outer surface of the cornea. And this lens is only providing adjustment in the focal length, so the light can be focused on retina. And 25 centimeter is a minimum distance from which we can see without getting any strain. This is the least distance of vision, and this is also called a near point of the eye. And what is then far point eye? This is infinity. So so we have this accommodation between 25 centimeter to infinity, in which we can even see objects closer to 25 centimeter, because then we will have a strain in our eyes, and a strain in our eyes. Without a strain, 25 centimeter is the minimum distance for the ciliary muscles and the lens to get accommodate without strain. So why do we have two eyes? Why not just one? It gives a wider view. two eyes gives a wider view. Human beings has a horizontal field view about 100 150 degree with one eye. So it will only give a 150. See, this is 360 and 150 will be this, something like this. And with two eyes it's become 180. With two eyes it's become this 180 degree. So this creates the wide like field of view. Set one eyes, the world will look flat, two dimensional. If we close one eye, the world will look two dimensional. And both kept keep both eyes open, the world will take three dimension. So it is creating two things. One, it is widening the view from 150 degree to 180 degree. Another second thing is also it is second eye, when both eyes also like transferring the view from 2D to 3D. Let's talk about the defects of vision and how these defects can be corrected. So we're gonna study here majorly three defects, which is a myopia, nearsightedness, hypermyopia, farsightedness, and presbyopia. So what is a myopia? Myopia, what happens in the myopia, we can see near objects clearly, but we cannot see distinct objects which are very far. So how this happens? This can be caused by the excessive curvature of the eye lens. If the eye lens excessively curve, it will bend the light very close. Elongation of an eyeball. If eyeball get elongated, its focal length, its focal length becomes short compared to the, and cannot form image at retina. So in this case, what will happen? We will use a diverging lens. If the image is forming before the retina, this is retina, and image is forming before the retina, it can be, so this can be solved by diverging some rays, and so that by slight diverging the focal length increases. So diverging lens is a concave lens. It slightly diverges and then forms image at retina. Another thing is hypermetropia, where the in this case we cannot see the near object distinctly. We can't see the nearby objects, however we can see the far objects. What happens in this case? The focal length of the eye becomes too long, it goes beyond the retina, and in second case the eyeball make it small. This is a normal eye, and if the see in case of focal length goes beyond the retina, or the eyeball structure changes, you know uh, get small without getting any changes in this lens. So again the focal lens will form before after retina. So how we can do it? We need a further a convergence lens is already doing a convergence of this rays. We need a further convergence lens, so that more you know the light can be converged more near, so it can converge at retina. So we will put lens here, it will converge, and then it will reconverge by our eye lens, and it will form image at retina. So we will use converging lens, which is convex. Third type of category is presbyopia, and the power of accommodation in this case is usually decreases by aging. This happens in old age, and it is difficult to see the nearby object comfortably and distinct without corrective glasses. So so the both things happens. We also lose accommodation ability in both nearby objects and far distance objects. So gradual weakening of the ciliary muscles and diminishing flexibility of the eye. So it was due to the weakening of the ciliary muscles. Over time, ciliary muscles weak, so it cannot change the focal length accommodating power uh, of our eye lens. Sometimes a person may suffer from the both myopia and hypermyopia, and such persons often requires bifocal lens. And both the concave and convex are needed in the bifocal. Concave will be to see objects at a clearly at far, which are far, and these are for the close objects. And upper portion consists of the concave, because upper we see this is the eye, and we see by the upper portion far far objects. And while we read and closer looking, we uses this lens, and the upper lens is a concave and the lower lens is a convex lens. So this is about the eye donation. And do you know that our eye can live even after our death? The people who uses spectacles and those operated with cataract and can still donate their eyes. People who are diabetic or have a hypertension, asthma patient, and without any communicable disease can also donate their eyes. An eye can be removed within like 4 to 6 hours after death, and it only takes 10 to 15 minutes for removal. But people who have having AIDS, hepatitis B or C, rabies, acute leukemia, tetanus, cholera, and meningitis and encephalitis cannot donate eyes. These people cannot donate eyes, and one pair of eye can give vision up to 4 corneal blind people. So this was about the eye donation. Now talks about reflection of light through prism. We have studied how the light works. Now we will study different phenomena like uh, you know through prism, how it forms the seven lights and the rainbow formation, the blue color of the sky and all that. When the white light goes through the prism, it breaks into the constituent wave lights. These constituent wave light are these constituent lights are called Vibgyor, because they forms a different color. They forms like violet, indigo, blue, green, yellow, red, and orange. And red has the maximum wavelength. Those light which have a maximum more wavelength will deflect less, and those with have a minimum wavelength will deflect more. So red in this case has a more wavelength, and violet has a least wavelength, and this happens in the increasing wavelength order. So these orders called Vibgyor. This band of color component of the light beam is called spectrum. These bands are called spectrum. And splitting of light into the components color is called dispersion. And this is light is getting splitted into its components. What are its component? These are its component. The 7 colors splitting into 7 colors in 7 different wavelengths. This is called splitting, and this phenomenon is called dispersion of light. And the light red band least because it has a most maximum wavelength, and opposite happens in a violet case. And Newton was the first scientist who first used the glass prism to obtain the spectrum of the light. And this observation gave the Newton the idea that the light was made of the 7 color. What he did, first he passed the light in from the spectrum, and the light disperses it from the spectrum, and then this spectrum was again passed through the opposite prism, and these 7 colors also formed the white light. So after this experiment, he concluded that the light is made up of 7 color. Let's talk about how the rainbow forms. Rainbow caused by dispersion of light by a tiny water droplet. So here the water droplet is acting as a prism. A rainbow is always formed in a direction opposite to that of sun. That means here will be our person I, and here will be sun, opposite direction. And the water droplet act like a small prism here, and they reflect and disperse the incident light, and then reflect internally, and then finally reflect again. So there are first refraction is happening, then reflection is happening, internal reflection, and then refraction again happening. So two refraction, first and last, and in middle there is a refraction. And so this is how it happens. When the sunlight comes, it reflects. There will be reflect. That means the light rays will bend towards the normal. Okay, and here the reflection, when it is forming as a total internal reflection. And why it happens? When you know the when the real medium reaches, has a more than the critical angle, the angle of incidents become more than the critical angle. Critical angle is when, let me explain this. We have know that the denser rearer, we know that when light goes is from denser medium to rarer medium, is bends away from the normal, this way. So if we increase the incident angle, the light will bend more and more. So the angle in which the light will form 90 degree, it will be 90 degree. This angle is called critical angle. And when we increase a critical angle, there happens a new phenomena which is called total internal reflection. So till critical angle, there is a refraction refraction was happening. And when we increase angle more than the critical angle, incident angle will be more than critical angle, then the total internal reflection happen. So the whole all the lights comes here, and the incident is followed the laws of reflection. The incident angle and reflecting angle will be same, and this is called reflection is happening. Reflection, FLACTION, reflection is happening here. So this happens here, the total internal reflection. This is why I have written L here, and this is refraction. And again, when it passes from the rear to denser to rear, it again there refraction happens. So first refraction, then reflection, and then again refraction happens. And we see the when this happens, the seven color, the white light forms the seven color. This is how we see a rainbow. So let's talk about the atmospheric refraction. So hot air is a lighter air, and which is less dense, and that the cooler air than the cooler air. So whenever sun heats the atmosphere, the atmosphere air gets lighter, and lighter airs remains up, and cooler air remains the down. And so these both have a changed reflective indexes. They both have slightly different reflective indexes, and lighter air has a slightly less refractive index than the cooler air. And these by these contrasting reflective mediums, light shows the phenomena of refraction. It reflects because the medium has changed. Why the medium changed? Because the uneven heating of the earth, uneven heating of the atmosphere, there forms two separate medium. One has lighter, which is acts as a rarer medium, optically rarer medium, and one which has a cooler air, acts as a optically denser medium. Okay, as through hot fluctuates, this wavering is thus an effect of the atmospheric reflection, a reflection of light by the Earth's atmosphere. Twinkling of the star is a similar phenomena on the much larger scale. So let's talk about the twinkling of star. Twinkling of star is due to the atmospheric reflection of the light undergo the reflection continuously because there is a hot air and cool air. So it's not like there is any layer between hot and cool line. It's slowly like hot to cool happens. It continuous like gradual change here. So gradually the refractive indices are also changing because of undergo refraction content. So it will go continuous reflection, and what will happen as a result that the light will bend slightly towards normal, and atmospheric reflection occurs in a medium of gradually changing refractive indices. The star appears slightly above, just above, than the actual position when viewed from the horizon. Further, this apparent position of the star is not stationary but keeps changing slightly, since the physical condition of the Earth atmosphere are not stationary. Physical conditions are not stationary. Its atmosphere always changes. So the intensity of light will also change. The path of the rays of light coming from the star goes on varying slightly. The path of the rays coming from the star goes on varying slightly. The apparent position of the star fluctuates. This apparent position fluctuates, and amounts of light entering the eye also flickers. Two things happens. The apparent position also moves here slightly, and also the light entering, the amount of light enters also flickers. It slows down and is bright ups. So star sometime appears brighter, and sometime it becomes fainter, and this is what we call twinkling effect. And why does the planet twinkle? Why don't the planets twinkle? Because they are much closer, and the much closer to the earth, and are thus seen as an extended source. And if we consider a planet as a collection of a large amount of a point sized source of light, the total variation in the amount of light entering our eyes from the from all the pin individual point sized source will be average out to zero, so thereby nullify the twinkling effect. So this is happening because of the this atmospheric refraction. So we also see another phenomena for atmospheric reflection, which is like advanced arrival of a sunlight. Sun is visible to us about a 2 minute before the actual sunrise. Why? Because of this atmospheric reflection, light rays should go this way, but due to the reflection it bends towards the normal and it reaches our eyes. When it reaches eyes, we see light as here because we see in a straight line. About 2 minutes after the actual sunset, because of the atmospheric refraction, the time difference between the actual sunset and apparent sunset is about a 2 minute, and the apparent flattening of the sun disk at a sunrise and sunset is the same phenomena. Let's talk about a different phenomena, which is like scattering of light. What happens like when the light wavelength fall into particle which is so small, it scatters. The light scatters here into different parts. The blue color of the sky, the color of the deep sea, the reddening of the sun at the sunrise and sunset, and some wonderful phenomena. We are familiar with this, and this is because scattering of light by the collider particles. We know that scattering light scatters by the collider particles, and the part of the beam of light passing through a true solution is not visible, and because the true solution has particle size far more less than the particle size which is in the collider solution. And however, the part become visible through the collider solution where the particle size is relatively larger. So what happens is, we have studied in the collider solution, when light is passed, we see the light, we see in a collider solution, when the light beam is passed, it, we can see inside the solution light beam, light is passing. And this is happening because of the, when the light wavelength is uh, light wavelengths come with the particles, and the particle reflects the light into all directions. So as light is a white light, so all the wavelength got reflected. If the particle size is more, all the wavelength, that means all color of the light, like blue, indigo, red, green, yellow, violet to red, all the light particles will scatter. And when all the light wavelength will scatter, then all seven colors will form white light. So when in collider solution light is passed, it scatters and it show the white light. What happens if the particle size will decrease? So this happens by this, there is a law which is called Rayleigh scattering. And when the particle size is very low, less, like oxygen molecule and nitrogen molecule, which are in the atmosphere, oxygen is O2 and nitrogen is N2. They are atoms of only two molecules of two atoms only. So it is very small. So what happens is, they have a much smaller wavelength than the light. So we have a law, the wavelength, intensity of the scatter light is inversely proportional to wavelength, fourth power of the wavelength. So more will be the wavelength, less it will scatter, and less will be the wavelength, more it will scatter. So we know that red has a large wavelength, and violet has a I don't know, Vibgyor. This is a Vibgyor, Vibgyor, and it has a it is large wavelength. This is a least wavelength, small wavelength. We are doing comparison. So this wavelength increases this way. So by this law, this is a large wavelength, so its intensity of scattering will be very light. These light will not scatter, so these light will directly come into the earth, and it will not scatter in our atmosphere. However, these lights, violet and these blue, and this will be most scatter. you know the blue light, the violet light, and then blue light, violet, indigo, blue, these are the three guys. More it will scatter, then slightly less than this, slightly less than this. So these three guys plays a major role, and these scatters most, and that is why the mixed color of these three, in the with the greater proportion of this, with slightly less of this, slightly less of this combination, all these colors forms the sky color. So because of this formula, so this is a particle. Suppose this is an oxygen molecule, okay. This is a oxygen molecule, O2 here, double bond, and triple bond, okay. So when the light wave will scatter, it contains seven color. And as the this red light has a large wavelength, it will not scatter as much, so it will directly goes there. And the violet and the blue lights and indigo lights, which have larger wavelength, will scatter, and it will scatter light in all direction. These are violet blue, green. So mixture of these violet blue greens gives us sky color. This is how our our atmosphere appears. uh, you know Not actual blue, but it has a mixture of these major these lights. What is a Tyndall effect? We have already gone through it. Atmosphere is a heterogeneous mixture of the minute particles, and these particles include the smoke, tiny dust, and droplets, and suspended. These smokes and tiny droplet particles, these are very large particle compared to the molecules of these oxygen and nitrogen. Okay, dust particle will be far more larger than this. When beam of light strikes such a fine particle, the path of the beam becomes visible. And this phenomena of scattering of light by the colloidal particles gives to the Tyndall effect. This we have already studied in the ninth class, mixture and solution in mixture chapter. And the color of the scattered light depends on the size of the scattering particles, and the very fine particles scatters mainly blue lights that we have already discussed because of this formula, Rayleigh scattering. And while particles of large size scatters longer wavelength. If the size of the scattering particles is large enough, then scattered light may be appear white. Why? Because if the scattering particle is large enough, it will scatter all the lights. V V to R, all the forms of light. So these all the seven color will form the white light. This is the region milk is white, and the foam, the soap foam is also white because of these reasons. Why sky is blue, that we have already discussed. Let's quickly revise it. Fine particles of the atmosphere have a size of the smaller than the wavelength of the visible light, and these are more effective in the scattering of light of the shorter wavelength at a blue, and then light of a larger wavelength at a red end. So the red light has a wavelength about 1.8 times greater than the blue light. Thus the sunlight passes through the atmosphere. When sunlight passes through the atmosphere, fine particles in the air scatters the blue light, a shorter wavelength, more strongly than the red. And this scattered blue light enters in our eyes. You might have observed that the danger sign uh, signals are in red in color. Why? Because the red light scatters by fog, least scattered by the fog. The blue light will be scattered down, it will be scattered down. The red light will least scatter, therefore can seen uh, in a same color at distance. Suppose this is the pole, and here the red light will go this way. It will not scatter. In case of blue light, it will scatter. The particles will scatter blue light, so everything look blue. Color of the sun at sunrise and sunset. This is again with the same phenomena. Why? The light from the sun near the horizon passes through a thicker atmosphere or thicker air, and the largest distance of the earth atmosphere before the reaching. So when the earth is sun is rising, it has to travel a large, uh, large atmospheric distance to reach our eyes. So due to this, what happens, the same phenomena, scattering happens. And when the sunlight is above our overhead, it has to comparatively pass travel a less atmospheric distance, so it has a less possibility of scattering, is a more time for scattering. So however, light from the sun overhead would travel relatively shorter distance. At noon, the sun appears white as only the little of the blue or violet color scatters. So at the near horizon, most of the blue light and shorter wavelengths are scattered away by the particle. Therefore, the light that reaches our eyes are the longer wavelength. This gives us to radius appearance of the sun. So the most of the blue light, it has seven lights. It has a blue to red, so violet to red, violet, blue to red. So as these lights scatter most, this will as this will scatter down this way, this way scatter down, scatter away by the particles. And red light, which least scatters, will reach to the earth. Red light and you know a light before a red light, so these are the lights which least do not scatters much and reaches to our eyes. This is why we see the eye reddish color. Let's quickly revise this chapter. The ability of the focal length, the ability of the eye to focus on the both the near and distant objects by adjusting its focal length by the help of ciliary muscles is called accommodation of the eye. And the small distance we can see clearly without a strain is a 25 centimeter. This is without strain is important, because we know that I can see very close, like 5 centimeter distance. I can even see it in 10 centimeter. We usually use our phone very close when we usually sleeps, like 5 to 10 centimeter, but this causes strain in our eyes. So this 25 centimeter is a without strain distance. So myopia is a short-sightedness which can be where we cannot see the far objects. I have learned, let me give you one trick. This is a myopia, and another thing is hypermyopia. So in alphabet, H comes near and M comes far. So these are the defects. So these are the disease. So when the defect is closer, in alphabetically series, H is a closer. When the defect is closer, that means it is hypermyopia. Closer defect means we cannot see close objects. When the defect is far, FAR, then the defect is myopia. So this is a trick. H comes first, so it comes as in alphabetical series A to Z. H comes close, it comes first, so it is we cannot see close. It is a close, then we cannot see close objects. And M is a far, then in myopia we cannot see the far objects. These are the defects. Okay, and these can be corrected by this myopia can be corrected by the concave, and this is by the convex. And the splitting of the white light into the component is called dispersion. When the light splits into its component through passing through a prism, it is called dispersion. And scattering of light causes a blue color of the sky and reddening of the sun at the sunrise and sunset. Here ends this chapter.